So guys, we might get started. Don't stress if you don't have the files yet, because I'll just talk a little bit at the beginning. Are we recording already?
Yes. Yeah.
Thanks. So yeah, I'll just kind of give a little bit of an introduction, and if you don't have the files, then just keep trying to get them. There's I'll put that other link back up, so you can get it from one of the thumb drives going around, or also if you just go to the 4V website, it's on the shop box there. Thank you very much for coming to our workshop. It's about instance noodles, so if you're in the wrong room, now's a good time to find the right one. My name's Kyle.
Heyo! I'm Mangosh, Evil. Heyo!
And yeah, we're wanting to give you just a bit of a run through of instance noodles today. Can I just ask to have a little bit of an idea of where people are at? Hands up if you've used instance noodles before. Okay, and if you've never used it?
Yeah, we got some beginners, bro.
Yeah. Cool. Does anyone write shader code? Yeah. Is anyone interested in shader code? Yeah. Cool. All right. So yeah, I think that's fine. We'll mostly just be using modules rather than doing code stuff. Towards the end, we will sort of just go through a little bit how you can make your own module, and also that writing the code isn't actually that scary. Yeah, basically, in a nutshell, instance noodles was just intended as a way of using the visual flow paradigm that we're familiar with from 4V, but for patching on the GPU. So it's not a magic bullet. You can't really do stuff with instance noodles that you couldn't do by more conventional means, but it can be a really fun way to prototype on the GPU. So a really good use case is anytime you're having mini objects or this sort of thing, or if you're wanting to manipulate geometry on the GPU, then that's where it's a good use case. Just to kind of give a bit of context for it, if you're just patching 3 things doing something, it's probably a lot easier to just do that with normal 4V. So that's when you wouldn't use it. There's a bit of a, I might just bring that patch up here. Don't worry if you don't have it on already. I just want to kind of use this to have a context. So yeah, basically we'll be going through a couple things today. Really broadly speaking, you can break instance noodles down into compute stuff and geometry stuff. I think it somehow was more known for geometry. Personally, I'm much more interested in the compute side of it. It's really, really powerful and very general.
And very modular. Sorry, because I'm also a big fan of the compute stuff in instance noodles. And the point of it is that you can really chain things together and modularly add a feature to whatever you're doing.
Yeah. So we'll kind of just look at how that actually works with the compute shaders and the geometry shaders, and then later on we'll also have a look at kind of what sort of functions you have available if you want to write your own, and we'll also look at a bit of a kind of real life project from some guy.
Some douchebag!
So this patch is basically just like a...
Anyone into files?
Files, anyone?
Okay. USB maybe, just to get it back.
Back enough.
Oh, it's yours.
That was
It's the same as the pack files.
Is that running for you? No. This guy's getting a black screen, by the way. Because there's no workshop files for those. Oh.
Hey, bro, do you mind just like helping him?
Oh yeah, sorry, bro.
What's the problem?
Okay, so if you're familiar with 4V, you're probably familiar with working with spreads. And this is kind of a point where it's just like a sort of similar thing when you're on the GPU, but a different data type and just different kind of workflow to manage. So basically, all the stuff you know with patching traditionally is running on the CPU for the most part. When we're going on the GPU, instead of spreads, we're using buffers. And in the case of instance Noodles, it's a particular type of buffer that's known as a structured buffer. It's not actually really a big deal. The structured buffer part's kind of a label that we use to make it human understandable. As far as the graphics card is concerned, it's just a memory allocation. But if you think of like some different data types, like a value or some vectors, in 4V normally it doesn't really distinguish so much between a value and a vector. Your vectors is kind of a spread, you know what I mean? Whereas with a buffer, you're kind of making that distinction. In DirectX 11, you have all these dynamic buffer nodes, and they're basically what you use if you want to move some data from the CPU and like upload it to the GPU.
So dynamic buffer is just a bridge. Some people get a bit confused with it, but really almost it does nothing but put some data that's on the CPU basically on the GPU. So if you think about how you use v4 normally when you do a spread, it's exactly the same. It's just that if you want to put a spread in a shader, in a spread, sorry, I see actually that a buffer is a spread, essentially. I know it's not exactly strictly in this because it's more strict and all this stuff, but just for like beginning understanding of shader code, a buffer is just a list of data, which is the same as a spread before. So if you want to put a spread in a node, you just put your spread inside a node in the pin. If you want to put your spread in a shader, in a buffer, you have to just put your spread through a dynamic buffer. The main difference is that you need to know the type. So as Kyle just said, we make a difference between a vector 3, or a transform.
So on any of these Noodles modules, actually it's pretty easy. If you just look on the pins, or even better, have an inspector open and look at one of the modules. So any of the ones in these chains that are like a Noodles one. And you'll just see on the inputs and outputs it's named when it's a buffer, and then you know that that's the type that it uses. The readback ones we won't go so much into really, but just to know that they're there, that's basically kind of the reverse process from a dynamic buffer. It's pulling data from the GPU back onto your CPU. In general, that's kind of a no-no. You want to avoid doing that if you can. It's a real sort of performance bottleneck. In some cases, though, you definitely need to. You know, if you're wanting to write some 3D geometry to disk or something like that, then for sure you need to kind of have it going in that direction. But in general, in terms of the pipeline of real-time 3D graphics, we're really only going the other direction. So, have you guys got this patch open as well? Yeah. Okay, so I'm just gonna really quickly kind of talk through the patch. We've got like our spread count here, and this is sort of a bit of a annoying thing with Noodles, is that you're kind of constantly connecting spread counts everywhere, but you can kind of deal with it. It's all right. So here we're actually just building our spread for like the initial positions on just in the patch. So we've kind of already got 30,000 values there. Because we're not wanting to change that, we can kind of upload that as a one-shot. You see how I've got the apply there, and that's taken off. if you look, there's actually like a help patch from DirectX 11 that really kind of takes you through. I think if you just take any dynamic buffer and there's actually a better one too. I thought it was this one. Doesn't seem to be working. Oh, maybe. No.
How is it if you keep the apply always switched on, so you constantly write to GPU? Is it as slow as reading back?
No. It's kind of a normal thing to be doing that. Just if you don't have to be refreshing it every frame, you don't need to.
Sorry, I'll make an analogy here, especially for anyone here that uses Unity. Or hey, I'm gonna go back, Flash and all that shit. Remember, you have like onload and on enter frame, or whatever, on update in Unity and kind of on start. And that's exactly what the apply pin is for dynamic buffer. So in Unity, what you would do is if you want to pass data to a compute shader in Unity, but you only need this as the setup in the init on the first frame, then you would do it just on start, right, in Unity rather than on update. And that's exactly the same difference with a dynamic buffer. If you have apply on, then it means that every frame you are pushing this data, whatever it is as a spread, into a buffer. Obviously, if this data is changing all the time, you got an LFO, you got an animation, or whatever data you're pushing in that's constantly changing every frame, then you must have apply switched on. But if you can just give the data as init value on start, on the first frame, whatever you want to call it, then you can just bang it on open or bang it when you need it, right? Or just turn it on when you need it.
And there are a few nodes also that actually generate really large buffers for you, so you can kind of think of them as like source ones. If you're familiar with using the texture effects nodes, that's actually kind of basically a really useful template for how to think about these. It's really working the same as the texture effects set. It's just that you're working with generic data types instead of a texture. Which is really handy because you can just recombine them in different ways, and then eventually a shader will probably use them to draw something at some point, but you can kind of defer a lot of the logic that way.
So question real quick. You
Yeah.
have the on open, so it just does it automatically when you start the touch?
That's right, yeah.
That's
Yeah.
cool. It's
Yeah.
visible though.
Yeah.
So even if you saved it off, it
Yeah.
still does it.
Yeah. Yep. So if you kind of want to go deeper into the dynamic buffer stuff, I think I just copied this from the DirectX 11 girl power, but it has some more infos. I don't want to get sort of too technical with that side of things now, so that we can just kind of focus a little bit on just the patching system. So like I'll just give you a quick peek like inside of a module. Basically, this is really similar to the texture effects layout. You don't really need to worry so much about the structure there unless you're wanting to make nodes, but essentially we just have a switch with our input so that when we disable the node, it's just passing through whatever buffer it had to begin with. And then we've got like a little bit of setup stuff for the compute here. That's the actual compute shader, and it's actually rendering a buffer out. So it's very similar to texture effects, and then after each module, it's basically like a discrete pass, and you have a result. So it's working a little bit different. I don't know, you may have seen some like DirectX 11 compute setups for particles or things like that, where it's more of a horizontal than a vertical layout. And actually, to do it like that, it's a bit more performant. So in that case, you wouldn't be doing a pass for each operation. This way is kind of advantageous because you always have the results available from each point, you know? Like here, I've got my 3D buffer, and I'm already using that result somewhere, and then I'm going to do some more things with it and use it somewhere else. If you have something that's a little bit more like a monolithic particle system or something, you don't kind of have this advantage of having kind of every stage of the processing available.
So I'll just add quickly that for when you're working with the compute stuff in Noodles, as he's mentioned, kind of, it's all about knowing whether you're dealing with 3D buffer or transform buffer, and some things are made for that. But if you're looking at, and actually that's kind of what I do when I use Instance Noodle, if I'm on the 3D buffer, that means that I'm dealing with X, Y, Z, as you would say, vector 3 position in V4, right? But you can chain these effects and chain them as long as you stay within the 3D buffer node in instance Noodle. So for example, if you do things like particle system, which this pretty much is, and you're dealing with 3D buffer, go in your node list and literally type 3D buffer.
Yeah.
And you'll get all the list of all the nodes in instance Noodle, and trust me, there's shitloads that do 3D buffer stuff. And like try it. Like
So if you're not familiar with the shortcut, that's just like Control N to do that, and I'm just gonna like do as he's saying.
Yeah. And so literally when I'm kind of prototyping, as we call it, I'm to do this. I'd be like, right, let me throw some curl, let me throw verlet, let me throw some stuff, and it allows you to basically write shader code without writing shader code, because all these modules, you could, if you wanted to, just actually write just one compute shader that takes each little function of each little node and like put them in a sequence. But the beauty of it is also the modularity of it.
Yeah, I guess there's some nodes that are like a little bit specialized with what they do. But actually for me personally, the most useful ones are actually like these super simple basic ones, because they're the best building blocks. So some of them do have help patches, unfortunately a lot don't, but a lot of the nodes are very much just kind of translations of what would be a normal 4V node. So you know, things like input more for oscillator, you can really actually just look at the 4V kind of standard node and look at its help patch to understand the intention and purpose of the node.
And sorry, I'll add quickly that actually this is another thing that's really brilliant about instance Noodle. Now we're just showing you how, and we've said how if you want to put your shit in buffer, you need to use dynamic buffer and stuff. But what Kyle's done actually is create a lot of those nodes, like wave shaper, like did you even do LFO or something like that? There's all these nodes are direct implementation that go into a buffer. So what I'm trying to say here is, if you're using an LFO to then put it in a dynamic buffer, then you could just use the instance Noodle LFO node, which directly has a dynamic buffer in it and directly goes inside the shader. So if you're going to be using LFO and dynamic buffer, or sorry, give me another one, wave shaper, there's quite a lot of
There's a patch we'll do
Right.
that's like
Alright.
source ones. Yeah. So yeah, like actually I could talk through this patch more, but I want to kind of keep moving. Be nice to.
Sorry, where is the LFO buffer? Is it in value?
Just type LFO and it should come as...
I think it might be like a wave spread actually.
Yeah, actually, yeah.
Okay.
There's a wave spread.
Yeah. So well, look at, since we're talking about it, we'll
Yeah.
jump to this one. If we go to compute sources, that's giving like some. Oh, hello.
Nice green.
Same here though. Same
Oh,
for
is it?
everyone, as far as I can see.
All lights green.
Everyone.
Okay, let's look at the help patch from specularspread instead.
Right, so jumping in there, there you go. There's a brilliant example. I'm sure most of you have used spherical spread in vvvv. That's exactly the same. It gives you a spherical spread, but essentially on the GPU. So it gives you a buffer of spherical spread rather than a spread of spherical position.
So there's like one thing I'll mention is some of these source nodes I've made where the spread size is actually spreadable. Does everyone get what I mean when I say that? It's okay if you don't, because I can explain it.
I don't get it.
Okay. So like, I mean, in this case, all it means is I've got these different kind of sphere spreads here,
I
but
get it.
actually they have different counts. So you know, this one has less in it than this one. But we're generating that all from a single node. In general, all of the compute nodes are not spreadable. They have a spread count, but you can't spread the spread count. For some of the source ones, I've made like a exception to that where you can. It still ends up, what comes out of it is still a single buffer. But But in the cases where you can do that, I think I've maybe renamed it bin size or something. But yeah, just to sort of indicate that you can do that. In general, with a compute, you can't. Just to know. So like these ones where they are kind of doing that bin sizing, it's got actually two outputs. You've got the normal buffer coming out here, which you can then use like the sprite buffered one's very useful for visualizing things. You have, if you type sprite, you actually have a 3D sprite node in 4V, but you're feeding it 3D values from the patch from your CPU. So all of these kind of nodes that have buffered on the end of them, if you type buffered, you'll see quite a few of them. They're all kind of actual shaders, or some of them are geometry shaders, but they're intended for having these buffered inputs. So it simply means that I take a spread, but I want it to be on the GPU already.
Push our geometry to superform, for example.
Yeah, for sure. Oh, that sources one wasn't working. Actually, want to have a look at these sprites also, just because it's maybe good to just talk about like what you actually do with the buffer afterwards, because it's all good having like this Lego that you can play with and you have buffers, but at some point you still want to draw something, right? So I'm just gonna leave the inspector on that sprite node. I kind of quite like this example just because it's like actually it's very few nodes and we've got a lot of objects and the computer doesn't really mind. Just attach that. So there's a little bit of a kind of convention, I suppose, that have used in instance Noodles, where you'll very often see the same parameter with actually a couple inputs. So you'll see like if you know like the foo bar thing from examples, you'll see like foo default and foo buffer, or like to be more kind of looking at what we have now, for example the size default and the size buffer. That's a good place to start. Yeah. So what that's actually talking about is if you in your shader make a input that's taking a buffer, that's great, and then you can use it to really like push millions of values to it and everything. But unless you actually have a buffer attached, the shader doesn't work at all. And I found this kind of to be like a little bit of an annoyance often when working with buffered things. So I made this system where you have a default value, and the default value is not spreadable. It's just a single value, but it's basically the shader saying, if I don't detect that you've given me a buffer, I'm just going to use this instead as a placeholder. And it's quite nice because often, you might not actually, it's nice to have the option to make them different sizes, but quite often you'll have them the same size. So like just to make an example of that, if we take this size pin here, so make one for it, and we're gonna make a dynamic buffer value. So this guy.
So it happens automatically. If you don't have a buffer, it will take the size by default. If you have a buffer, it will take the buffer, obviously.
And you can't like put a spread into the default.
No.
Wait,
it's not going to stop you from doing it, but it won't actually work. It'll just take the first value. Yeah.
I guess what happens under the hood maybe is that the default value is passed as a buffer anyway, or as in you fill a buffer with it and then
no, it's doing a size check on the
I
buffer,
remember
and if
these
the buffer
right.
size is 0, it'll take that one. Okay, so just here I've made a dynamic buffer value node and a little like three-piece suit. And I'm gonna attach that to the size buffer and break everything. Cool. Check that out. So obviously, since I've got the value set to 0 there, we don't see anything, but it should actually. Why is it still broken?
Push them up a bit more, maybe. Oh, maybe. Yeah.
Oh yeah, there we go. That's interesting.
So since there's 3 values in the buffer, each value influences a third of the particles. Am I right, or totally?
Yeah, but as soon as actually,
no, default is ignore. Sorry?
yeah, I'm just checking. That's probably not been the best demonstration of it. It's
Bug reporting already, guys. Nice, nice.
Alright, I'll double check that and get back to you. It's-
See, because now it's 0, you actually don't see anything.
yeah.
That's kind of weird. At 001.
I think that's just a little bug I might need to fix. But if we look at the color, for example, yeah. So let's just ignore that little embarrassing bug for a second. And if we move on to the color thing, it's the same thing. You've got your color default and your color 4D buffer. That 4D buffer, I think you can use either the 4D one if you want to put values in, or you can also actually just use a straight kind of color one. So what I just want to show is if you disconnect this dynamic buffer, it's like a 4D one, but it could also be a color one. Then it's taking this kind of default as the color for everything. As soon as that has something connected to it again, it's really ignoring this. This doesn't do anything anymore. So in general, that actually should work. So just so you can know about it as a kind of standard, you'll see that a lot, and later I'll also show you kind of the function that does that, because it's quite useful in shaders in general. Even not just for compute shaders, any shader that uses a structured buffer, it's kind of quite a handy wrapping function. What's that?
I know that's the velvet stuff.
So a kind of really nice thing when you are using this workflow of like starting on the CPU and then sending some things to the GPU is using data amplification. So that's where you're setting a few things, but actually on the GPU it's then kind of building up more sort of data points from that. So this patch, it's compute roulette, and it's just yeah, you know, if you it's quite often maybe if you have an agent or a particle moving around that you might want to leave like a trail behind it. You can do that with a queue, and there are actually instance Noodles versions of queue. But the roulette is a nice option for that sort of thing too. It just has a much more organic look. If the point actually stops, then you know you don't have the tail collapsing into it. So just to kind of explain what's going on is that the points we're feeding to it is actually just like the front point of each one of those, and then the roulette node is adding all of the trail points behind. So if we take a look at this guy. So it's a little bit unusual, or not unusual, but it's not exactly a source node or a filter node. It's kind of both, if that makes sense, because you still are feeding it a 3D buffer, but actually then depending on the roulette section count there, that's how big the spread count will get out. So it's got an outlet pin as well that's just telling you, just a helper sort of thing that tells you what the total is after it's added a bunch to it. So you can see, like, if you play with the V count there, it might kind of jump at first because it just has to, it's just because it's because of where it's storing the data. Basically, if you change the count, it'll change. But you can see there, you can kind of mess around with how many are being made, make them longer or shorter. In the kind of most recent update on all of the compute ones, I added this thread group size. I've kind of hidden that. If you look on the actual node in the patch, you won't see it. You'll only see it in Inspector, I think. But basically, you can just leave that one. The spread count is always important. The group size is not really so important. If you don't know what it is, you probably shouldn't touch it. It just, in a nutshell, it's just like on the graphics card when it's doing its dispatch, it's kind of how it's doing the batching and marshalling the threads. Does it make sense? But basically, it's kind of set at a pretty optimal point, so generally you shouldn't really have to mess with that. Does anyone like have any questions or anything? Like I can just keep going through some patches, but I'm not sure if you're yeah.
One quick question, because sometimes it happens that you want to change the numbers or the dots of the letters on the fly, or even the numbers, how many of them are being generated. And is there a way to do that so that not the whole system kind of flashes or
Yeah, essentially, yes, you can, but you're basically, you'd be computing both scenarios and then just switching between them. If you're just using the same compute shader, it's kind of just because of the way it's storing the values. It's it's like reserving like say we're doing 8 per piece. It's reserving 8 pieces, and each one's actually kind of looking to what was happening in the one before last frame. So then when you change it, that kind of looking at what happened last frame isn't really valid. If you actually think about the logic of it, if you're changing them, it's not always clear too. Maybe if you're making it smaller, but if you're making it larger, even if you did want to reprogram it, it's not necessarily arbitrary how that would actually work.
Yeah. But how would be how to set up these different scenarios? Because sometimes it's not predictable how many. I mean, if something is interactive, you don't know exactly how many prayers or whatever you would like to generate.
Yeah. So like you can use things like indirect dispatch. That gets a bit more complicated to set up and has some problems that it scrambles the order of things. But like for example, if I was doing this patch as an example and we wanted to just change how many of the snakes there are or something, one thing you can do is like you scale the ones that you don't want to 0. So there's this kind of thing you can do, which is sort of a good workaround. It sounds kind of wasteful because it's still like computing all these ones, but actually like we could add a lot more before it'll even slow down. It doesn't really care about it so much.
It would be easier to do that as well, and yeah, I don't think it will impact the performance. It's probably faster to do that, not just code-wise, but optimization-wise, it's faster to do that than most of filters that are gonna just kind of indirectly filter shit, I guess.
Yep.
What's the IID?
Sorry?
The second node, IID after steer.
That IID one is for instancing. It's just a helper for instancing, and it's quite handy, and we'll get into it in the geometry part shortly. Yep. Is any more questions or good to go on? Yep.
Can you do general purpose stuff, like not graphical, with these nodes?
Yeah, what would you like to do?
It's like, I don't know, like linear algebra maybe or something?
Yeah.
What, sorry?
Yeah, I mean, basically, we kind of already have our results in buffers. So, yeah, I mean, it's just a matter of what you then want to do with that. If you wanted to eventually, like, read it back to disk or, yeah, I mean, I guess, like, if we've got stuff on the graphics card, we either just want to take the data back, which we can just use read back for, or we want to draw it somehow because that's how we get it back again as information. But yes, in general, sure, you can. I mean, it's basically doing that already, just at the moment we're usually chaining them and then eventually feeding it to a shader and drawing something. If you are into like writing shader code, you might check out like in the packs it gave you, I've sort of refactored a lot of the functions in Noodles into some FXH files. So you've got kind of all these guys, and there's some just commonly used functions there. So you can use any of those headers if you want. So I want to look at one or two more compute examples before we get into geometry. Maybe this one. So this is probably an example of a node that's a little bit more sort of specialized. I just kind of had a particular time when I needed it and I wanted it on the GPU. So sumup is actually like a normal 4V node as well. And it's quite often used for like if you have sliders, if you want to like pull a value up and down, but to also keep it constrained within a range. If you think of like using like a OSC control thing or something, you might use the sliders, but when you keep dragging up, if it's at the top, it should just stay at the top. So if you have a look at this one, you can actually kind of move around this sort of brush with your mouse, and then if you click, you're actually pulling values up and down. And so we've got the sum up down the bottom, but I wanted to go through this one just because it's an example of sort of embedding a fair bit of logic that normally we would have to write out in a shader just in the patch. So we've got so the sample stuff here, it's really just like about the mouse button, so it's only doing it when we're clicking. But we're basically pulling the kind of XY values from the mouse out, and we're just also looking at this frame difference is just taking like if we're dragging up or down. So we've got here, this is actually like a buffered version of linear spread. You could also just put a normal linear spread into like a dynamic buffer node. It would be the same. We're making that linear spread buffer into a 3D buffer here, using the cross.
Can I ask, did you ever try and compare the performance between using a normal linear spread into a dynamic buffer and using your GPU linear spread?
I never did. I can try now if you want. It's probably going to be like really embarrassing.
We just assume it's better to do that. So remember, kids, use the GPU linear spread because for sure we know it's better, yeah? Scientifically proven.
If you go up in numbers.
Yeah, I guess at the start it probably isn't, and then maybe when you go high enough, this needs to be connected to something. So here it's kind of actually still the normal one. Yeah, so you can see like the one on the right's not really going up, but let's add another 0 and probably crush it.
Should you look at the pipeline statistics? Because these numbers maybe are...
That's actually a good point. Having said that, I know that this is not like slowing down on the GPU at all. It can go a lot higher. Like yeah, it's actually at the moment we're still just in thousands.
But if you put linear spread into dynamic buffer, is it the same or not?
We spoke about this for...
Well, actually, I mean, for the dynamic buffer one, that's going to be on the CPU one, so it will actually also, you know, at the moment that's just a calculation on the CPU. We actually then also have the overhead of having to upload all of that to the GPU. I won't make a shader now because like it's actually not so important, but I think basically the kind of in a nutshell, it's more or less as you would expect. If you're just using like actually, you know, less than 1,000 objects or something, the CPU is actually more performant. Having said that, it's still sometimes more convenient to do something on the GPU. You know, if you have a shader that's expecting a buffered input, then it doesn't really matter if you only have 3 things. If you want it on the GPU, you want it on the GPU. But yeah, like as you scale it up, it'll definitely kind of get more of an advantage if it's the buffered version. So I might just like explain this patch a little bit. We've got this vector 3D distance one here that's just taking the distance between 2 values. Again, if we look at this, we'll see we've got this kind of default buffer thing going on. So like with that one, if you wanted to compare a whole buffer of 3D values to a single value, you could do that. You'd just use the default on one side and the buffer on the other side. So actually in this case we're doing exactly that. I've got the value from the mouse. Since that's a single value and a CPU value, it doesn't really make sense to use that as a buffer. So I'm just putting that into vector 2 default. And on the value 1 or vector 1, we're using this buffered input. And so all that's doing really is we're working out the distance from where the mouse is to where one of the instances are. We've got this gamma value here. That's going to like a gamma node, and that's kind of basically effectively making like the brush softness. This isn't kind of really like a proper tool or anything. It's really just made to sort of illustrate it. But if you wanted to make like an actual proper kind of soft editing tool, there's no reason you couldn't. This simple operation one is probably poorly named. It's basically just what you use for your plus, minus, divide, subtract. So that's kind of important to know. I nearly this time actually replaced it with nodes that are just plus, minus, and subtract because it's easier to read, but it would have broken a lot of patches and made a lot of mess. So yeah, I don't know. I might still do it at some point. just be warned. So if you actually look on that node, you'll see it's just got like a enumeration. So at the moment that's being used as a multiply, but you can just kind of select which operation you want to do. And you have kind of versions of that same node for the different data types. So you can see if I get a simple operation, it's there for like vectors as well.
Once you put 2 buffers in there, does it behave like spreads in terms of addition?
In general, buffers are not spreadable. You don't have multi-dimensional spreads. It's just like a 1D spread. Unless you mean like a buffer in each input.
Yeah.
Because in that case, it's really then depending on the logic of the node. So it's still only outputting a single buffer. In the case of the simple operation one, or the distance one, we're really just doing kind of a comparison, or we're just adding them or multiplying them in this case. So what we end up with is still one result. It's literally the same as like you know, having a plus node. We've got like a value here and a value here, and yes, actually, if we spread this one, then we'll actually get a vector out. And it works very much the same way. I've kind of put like some wrappers on the buffer, so it does this modulus operation. Some people I can see are kind of nodding like, oh yeah, that's modulus, cool. If you don't know what that is, it's kind of just the default behavior in 4V with spreads. So you know, like if you have 5 things and then you index over that, so you're like 0, 1, 2, 3, 4, 5, 6, and you've gone over, it's just kind of wrapping at the start again. And if you use 4V, you're kind of just used to that just working. Normally on the buffer stuff, you have to take care for it, but it's kind of just been made in Noodles to emulate that same behavior, that it just wraps. And it's quite handy, you know. You can actually use this to kind of make quite large buffers from smaller buffers. So, you know, if you have a buffer that only has 8 inputs and a buffer that has 11 inputs, the way that they overlap and repeat will actually change. So you can use that to feed it into, you know, if you give that to 50,000 objects, it's not like a buffer of 50,000 different values, but it still will kind of vary in a way that seems somewhat random.
But it's the same, so if you were to actually write a compute or another shader with 2 buffer as input, it's up to you to do whatever you want with the index of, for example, if you want to add takes 2 buffer, takes the first element of the first buffer and adds it to the first element of the second buffer. But if you want to write a compute that adds the first element to the last element or the second element, that's not a problem. What happens is just important to remember that buffers as input don't spread, and what matters is the real output of it. If your output is a 3D buffer, but yet if you're outputting a 3D buffer, but you could have 2 inputs as transform buffers that take 2 transform, extract the X, Y, Z position, does a mean comparison, and then spits back the 3D buffer. The input types of the buffer doesn't matter. What matters is the output type of the node.
Yeah. So like following down, actually, now that you mentioned transform, we've mostly been looking at kind of like a value buffer or a 2D or 3D buffer. You also actually have a transformation buffer as a type as well. So it's kind of like the GPU equivalent of having a spread of transforms. And so like again, if you kind of want to like play with those, you can actually just write in the node binder transform buffer, and then it'll have a bunch come up. But like if we look at that node there, I won't talk too much about these. This is just doing some very simple kind of offsetting and addition with the simple operations. But if we look on the translate one, we can see actually I haven't really named it properly there, but the value inputs are like the default. It's the same sort of thing. So like if I want, I can put a X buffer into the X one and just set the Y manually. You know, it's quite often that you'll want something spread in one dimension, but maybe the same in another. This particular version of translate is kind of like the equivalent of the normal node translate, but then you also have a vector version. So like if I go translate vector, it's basically the same, but you can see it's actually taking a 3D buffer. And again, the first input is that kind of default sort of thing.
I think it's important to note for these nodes, because we've been talking since the beginning about, I'm telling you, if you want to do stuff with 3D buffer, type 3D buffer in the node list, I keep adding shit. He's just showed you how you can work on transform buffers as well. However, this translate node also works as a bridge between a 3D buffer to a transform. So there are nodes in Noodles which do convert a 3D buffer to a transform. It's a different type of structured buffer or whatever, but when you in vvvv normally take a spread of XYZ position and put it in a transform node, normal transform, normal spread, it does that. It takes a vector 3D, a bunch of position, and converts it to a matrix, to a transform. This does the same, but on the GPU. But it's important to note there are certain nodes, like translate, like get matrix post, things like that, which allow you to wrangle from a 3D buffer to a transform, and vice versa.
I might not always have been consistent, but in general, the node is named for its output type, if that makes sense.
So get matrix post will allow you to go from having the transform buffer, therefore the spread of transform on the GPU, and convert that to just get the position. Again, if you guys do Unity, in Unity you call it extract, translate from matrix or whatever. It's the same. Essentially, originally we have a transform buffer, and what we do is we ignore, as probably a lot of you know, a transformation matrix is like 16 numbers, whatever. This actually extracts just the XYZ position and passes that as a buffer.
Also, I'll just remind you that it has a spread count inlet, because we've mostly just been working with kind of pre-made patches. But if you're kind of like whipping something up from scratch and it's not working or the behavior is weird, just check if the spread counts are connected. Because normally, like in 4V, you know, you're quite used to maybe putting a spread count up the top somewhere, but then in the chain of nodes, you don't kind of need to keep doing this. So like here, it's more a case that, I mean, I've hidden these, but if you look at these ones, yeah, I'm just trying to make it visible now.
Try Control 6 will make the patch darker.
Oh yeah, there we go. So you can see, like it's kind of unfortunate actually. There's a lot of connections, but you kind of just get used to it. But yeah, like if it's not working, that's like often the reason why. You know, if this one like down here, say, oops, yeah. See if I disconnect those, it's.
Goes to the default.
The spread counts, they're the number of elements, whether it's a 3D vector, a transform, or a single value, right?
Yeah, exactly. That's a very good point. So the number of elements, which means that if I have a 2D buffer with a spread count of 2, then I just have 2 units of those 2D vectors. So I mean, you can also think of it kind of as 4 values, but it is 2 2D
feed
vectors.
4 values into that thing. Fill it up.
You'd feed 2 2D vectors.
And the spread count
Yeah.
would be
But it's important to note, sorry, that, and this is why it's a very, very interesting point that's been raised here. If you're in gate matrix pose and you have 64 transforms in your buffer, you're gonna get 64 3D vectors, which is actually very different. In V4, actually the matrix is 16 numbers, whereas the 3D buffer is 3 numbers. So it could be confusing if you're comparing it. But that's where shader coding shows how much stricter the data types and stuff like that. It's a number of elements. So if you are taking 200 transform and you want to extract the XYZ position, or could be direction or whatever, you still need 200 transform input gives you 200 3D buffer, not like 16 divided by 3, you know? Number of elements.
So you can see to actually render this down the bottom, again we're using like one of these buffered nodes. I don't know what else there is, there's probably not heaps of them, but yeah, so you can see if you type buffered, these are just some of the kind of ones that are actually made for display of the data.
What happens if you now take one of the nodes and you put half the spread count? You just lose half of the data the first half, you get only the first half?
It probably depends on like what's actually going on in the patch, but we can try if you want. So I'm just gonna take whatever the spread count is and halving it. And which node do you want to break?
Put it on scale.
Yeah. So we've yeah, basically
If you
kind
double
of.
it, what happens?
Actually,
Loops
above
it
that it would still be computing all of it, but when we get to that scale, because the spread count's half now, even though it actually still has access to all that data, it's only gonna run its routine until it gets to half the times. I mean, if you can probably actually even see it if we move it manually, it'll kind of start creeping there. See?
What if you go higher?
Either nothing or something bad, I guess.
Well,
Yeah, so
just ignores it.
doesn't. Yeah, it doesn't seem to mind. I wouldn't really recommend it. Like, generally, I guess in the shader, what would be going on when it's getting higher is it's just kind of wrapping, so it's just coming back to the first one a bit. But you'd basically be kind of writing the same value multiple times, which you probably don't want to do. Yep.
Could you explain what the difference between map and sumup is?
Yes. So map is essentially kind of just a GPU version of the map node. And if it's quite a useful function. I think it's got its own FXH file in those header ones as well. So if you want to use map in your shader, you can as well. So I think that does everyone know the map node from 4V? Yeah. So it's just the equivalent of that. The sumup is a little bit different. It kind of has a map function internally in it, but it's doing some other things as well. And It's kind of a good example of one of the limitations of patching this way. The reason it has to have like an internal map node in it is because it's doing some other operations in a loop. And you can't actually really patch loops of compute shaders. That's like a, yeah, I mean it's not that often that you would need to, but that's good to be aware of as a limitation. I don't know if that answers your question.
Sumup allows you to do like add frame difference from a mouse, and it's going to increment it, right?
Yeah, so we can actually just, if I grab the...
Is anyone else having problems, by the way, with instance noodles or whatever? So working for you guys, yeah?
It's like an integrate and a comment.
Yeah. Depending on the map type, but basically you're just kind of adding a value again and again, or incrementing it again and again.
To store the actual modifications.
Yeah. So it's inside the node, and that's also why it has to have the map inside as well, because it's keeping its state inside, and that's the sort of thing that then it's a bit tricky to just patch that. Because normally, I mean, in general, patching states is a pain in the ass, but like you're using frame delays and a loop to do it in normal 4V patching. You can't do that with compute. I did actually make some frame delay modules for it, and a couple people were asking me why they don't work. And it's just because you can't make a feedback loop. It's still useful sometimes to have a frame delay, because you might want to compare the current frame to the previous frame for lots of algorithms. You know, if you want to work out what the velocity is of a moving value or this sort of thing, it's still quite useful. But you can't do these kind of frame delay loops that you might know and hate.
Yeah, it's not a bad thing, bro.
Was there like someone else also asking a question? No? Okay. So yeah, and then we're kind of just rendering our results with this constant buffered. Again, you'll see this kind of IID. That you see that really anytime that using instances in instance noodles. We'll get onto a patch explaining that in a sec. Basically though, it's just that because we're using instances, we've got like our geometry, and in instance noodles I've made like a separate buffer that's just kind of, IID is for instance ID, and you could actually have that inside the geometry as well. There's reasons I chose not to. But basically what that kind of ID buffer is letting us do is to address all of these separately, you know.
And
so for example,
them individually as well and things like that as well, right?
So you know, we've got this this kind of color input that's buffered, and that's why, I'm sorry the contrast isn't great, but that's why, you know, you've got the different in coloring there. So like if I was actually to disconnect that, the whole thing's disappeared, and it's actually still got all those boxes, but it really needs that to address them. So it's both the color, but even the transformation on that is a buffer as well.
I think it's good to see IID. Actually, I was a bit confused about IID at first, as in like exactly what it does or whatever. But just I think it's good to think about it like a cloner that also gives an ID. So when you use constant buffered, you're doing what's called geometry instancing, which essentially means that it's the most optimized way of cloning a model to different position. And for example, before in DirectX 9 it was way slower and you didn't have that. This allows you to kind of, it's not free, but to very cheaply clone a 3D model or geometry, but it also gives it an ID so that we can then select it. So it's almost like if you guys, some of you are into the web, it's like a CSS class and stuff like that, you know? So that we can then just, or more an ID, sorry, CSS ID, so that we can then use a selector to target exactly that element. So without that, you wouldn't be able to have different textures or different colors on your different clone. Without the ID system, if you just done instancing, you would just clone your model along with the data that comes with it, like color and all this stuff. So this allows us to make special use cases for our clones.
But like if you're not doing a bunch of geometry processing or something, and you really just want instances, really all you need is this, and then you have like whatever geometry it is that you're instancing going on that. And I mean, in DirectX 11 you've got nodes that do this.
Yeah.
All it is a bit of a helper that kind of takes care of that side of it for you.
I was going to say it's just actually an instancer under the hood. If you guys have used the actual instancer on Node DirectX 11, but it has some fancy IT stuff in the background, which is really useful. It's really useful.
So there's kind of some B-spline nodes, I think, both for the data types, and this is actually the transform version. In previous versions, they were called bicubic, which was quite vague and somehow incorrect. So they've been renamed as B-spline. So if you've used them, that patch is probably broken. Sorry about that. But in this case, it's again kind of like a little bit of data amplification going on. So it really is, if you look at kind of the GPU version of B-splines, it's the same idea in general. Don't actually know what that has as a help patch, but this is maybe good just for understanding the concept if you're not familiar with them. We're just moving some control points and getting like a smooth interpolation between them. I think there's some versions of this for so yeah, you've kind of got it for, I don't know why I have it twice there, maybe the workshop and the library, or I don't know. Anyway, you've got it for like value, 2D, 3D, and transform. So on the left here, we're actually just building up a dynamic buffer for the control points. Here we're telling it kind of how many control points to expect. And so like what the way a B-spline works in general is you set up those control points, and you can think of them as like making your kind of railing, and then the input is basically like a normalized value that, you know, if the path is from here going to here, this end would be 1 and this end would be 0, and so then you can move objects along that. I think it's probably the input isn't set up for it now, but if you want, I'm pretty sure they all have, you've got the difference between bicubic or bicubic looped. Looped just means that you want your last point connected to your first one. Does that make sense? As we're doing it now, we don't want loops turn on. If I turn it on, probably when they get to the end, you'll see them. Yeah, does that make sense? But like an example where you might want that is if you're having like objects that are following some kind of path where they should kind of go around and then come back to where they started, or if you think of like, you know, when you have a camera follow a path as a loop, that sort of thing, you don't want it to kind of have a stutter or jump from the end to the beginning. So that option's just making it like a closed topology.
Can you do some sort of like arc length or whatever that's called? You know, where you like make sure all the points are equally distant across the spline? Like spacing them equally.
Yeah, not on GPU. I think the best way to do that is actually like, because usually your control points aren't like a massive amount.
Yeah.
So actually the easiest way to do that is to basically, you can make your control points themselves from a set of control points, and then they're already kind of normalized. And then when you're using that as your input,
That's a
it's
good
fine.
idea.
Yeah, I think
It's a hack,
even
but-
even like if you look at the help patch from that plugin, I think is it Arch Length or something?
What?
Yeah.
There's it's a, I don't think it's in standard 4V, but it's like a contribution.
Yeah, arc length, right?
Yeah. I'm
It is now in VL.
okay. I'll look at the old one first. Oh, that's a VL one. Okay.
Yeah, it's everywhere. Yeah, it's just very useful because I don't know if this is the one. Wait.
You know the one I mean.
Sorry?
You know the one I mean, like
The one
this
from-
one that's like making the values kind of normalized for distance. if you
Yeah,
have that.
I can't remember what it's called though, but yeah, I know exactly what you
So many
mean.
times, and now I can't find it.
Yeah. But yeah, basically, but the way I would do that would be to do it on the CPU with your control points, because usually you have like a lot of input points and not as many control points.
Yeah, the thing though, if you then use the looped, right, then it's gonna kind of screw it up. Because when you do looped, it's gonna do this big jump from the first point to the last point. So you have to position, I guess, the first and the last one.
Well, you can switch between looped or not looped.
Right. But if you do one loop, then you have to take that into account before.
But that's a good point. Sorry. Yes. Sorry. I would say you're right. If you were using loop and you make your first point the same as your last point, while spreading it visually, I know this isn't like amazing solution, but that should work. The problem we're highlighting here, and I'm keep jumping into Unity, man. I must be doing too much of this shit at work. But we've had the same problem with doing GPU splines in Unity and like trying to use them as path. And the problem Pedro's highlighting is that if you've got 2 points that are this far and then 2 points that are just this far, then you will go and then really quickly like that. So you're not going to get constant speed for the elements. And I don't think there's any real magic solution for this.
There is a node though that does that, and I'm sure it can be a compute version of it.
That's what I'm saying, but yeah, I don't know, because the problem is you might end up the solution of respreading maybe visually the control points or whatever. The calculation of it could be so intensive that it doesn't make it worth it on the GPU. I don't know.
It's no longer a B-spline.
Sorry?
It's
yeah.
different
Totally.
than a B-spline.
Sure.
Mhm.
Yeah, I mean, you start
Yes.
with this spline and then you make it like a. I don't know
But
what
you
call
could
it.
kind of, as you're reading the B-spline, you could hack it and say, how far am I from the next point, therefore...
I might just kind of keep
Yeah, so-
moving, because
yeah.
we've got like
Sorry,
a bit
yeah.
of ground to cover. No, it's all good. It's all good. So I think we'll look at one more compute one maybe before going over to geometry. Maybe another transform one if we look at transform feedback. This one's kind of a bit of a weird one, but I like it.
I love it, man. This is so fucking great.
So yeah, this one. Do you want to explain it?
I love this. This is so brilliant. I've actually totally copied and pasted this into some projects I've done, bro. So no shame here. But essentially what it does the old feedback loop with transform. So you start from a point and then you, would it be recursively? No, iteratively you go through and add a little bit of a transform to it. So yeah, it's kind of
Yeah.
Integration.
yes, it's kind of recursive and stuff, and it's kind of
I kind of like this one because it's also a good example of taking some smaller spreads and then using the way that they overlap to make quite a lot of diversity and variety. You know, like we've got this random spread here that's not that big. It's actually under 40. But because it's got that bit of randomness, it's basically saying, you know, every time I'm going to translate the thing a little bit and I'm going to scale it like one of these two different ways, and you end up with actually something that looks quite sort of different everywhere, even though the input values aren't like big spreads or something. So you've got actually, I think, a couple buffered inputs for the feedback itself. Can you just click on that one for a sec? Yeah, just so it comes in an inspector.
oh
Yeah.
yeah.
Yeah, it's I don't know if you can see over here. So you've got like your that first transform is just the kind of you can think of as like the source points.
Yeah.
So like in the Verlet example, it was that one that's in front. That's what it's using as a reference. And then
Sorry, so in our case, for example, so I'm just kind of trying to visually show it to you. Yeah, there's a good use for the cat for once, rather than looking ridiculous. This is your transform. As you can see, we've got circular spread. So that's our base pos. And then we're adding it, multiplying it. I don't really give a shit what you want to call it.
So you can see if I put iterations down to like 0,
There
that's
you go.
kind of our source So we could have any transform buffer that's building that up, and then as I do it once, it's applying this transform from the feedback transform to those. And as you do it more, it's not applying it to the first one, it's taking the transform matrix that the next one has and applying that again. And that's why we kind of have this effect of like, if we scale it, it's kind of, yeah, you can see it's reiterating over the same thing. In general, if you can avoid it, just to say, like, I don't know if you noticed when I was changing the spread count there that there was a very brief glitch. Usually you want to try to keep the same amount of geometry. You may not always want the same amount, but again, like I would normally, if I was doing that, would just like scale things to 0 or have them kind of waiting somewhere off screen. That's generally easier than actually changing. Because it's having to like do some things where it's indexing the geometry. You can see if I'm just changing the actual amount of it itself. Can you see that kind of like sometimes we're getting some triangles in the middle where they really shouldn't be? It's kind of fun. Yeah.
So for each level, you have 39 different with that value.
Well, no, that's kind of coming back to this nice thing of having offset amounts, because what it's doing is we've got the source transform is 41. So if you take like 41 and 39 and keep stacking them, actually the offset's always different somehow. Well, not always different. Obviously, it will repeat at some point, probably. But like it's actually the reason why it's kind of not the same at each step, and it's not even the same between each tentacle. And I mean, we can scale that up much, much higher. This is still like a very small spread count as far as instance noodles is concerned. And that's kind of cool because we're still not having to upload a lot of information to the GPU. So yeah, I don't know if that's kind of abstract with this small spread counts thing. For me, it's been something I keep coming back to as like quite a useful concept. Just as soon as you're combining a couple, you get like a lot of diversity with this wrapping.
So if you set it to 41 as well, it gets more regular.
What's that?
Set it to 41 and
That's a good thing we can try.
sort of.
Yeah. I mean, it's still a random spread up here, but you can see now actually that like from tentacle to tentacle.
But you're 42 now. One more.
Okay. Meaning of life.
Yeah, exactly. The answer to everything.
Yeah.
Answer for that question.
There's the uniform scale also. Remove that.
Yeah, we can make that the same and see also
How's
like.
it going?
Oops.
That's a nice spread.
Yeah, I mean there is a random spread in the wave shader anyway, but it's
But it's a nice thing,
it's
I
more
guess.
regular.
Change it a bit.
So we might just kind of like push forwards. I still want to be able to go through geometry and want to have a look at like example project. Whoosh.
Path vectors. Is
Before we kind of get into geometry, is there any other questions about the compute stuff? Is that all good? Yep. Are you asleep yet?
Yeah.
Path vectors was the node to resemble the spline.
Sorry?
Path vectors.
Ah, okay.
Was the node.
So we were wondering about this, like equalizing the distance on a spline plugin. It's path vectors. It's a really cool plugin. I think it's like from.
But it's not GPU.
Yes.
No, it's on the CPU. But usually
It's
that's
like
where you
Arclight, but it's
control
spread
points anyway.
Oh.
Yeah.
Herbst. It's cool. It's spread.
Okay, so our first geometry shaders.
Yeah.
So the geometry shader is kind of like a bit of a funny one in DirectX 11. If we actually go inside, like I've got a lot of stuff that's wrapping, so you don't need to take care for it. But the actual file itself, like the shader file, is even a different type, both in the terms of the type here and even the extension. It's not an FX, it's a GSFX. And basically, as I understand it, it's like maybe, you know, from texture effects in DirectX 9, it was always a module. In DirectX 11, Vox made kind of like just a plugin where it's basically having the render built in, so you don't have to do this. The GSFX is kind of the same. It has a stream out renderer, but there's still quite a lot of extra boilerplate you need to take care for. That's just done inside the module, really. You don't really need to worry about that if you're patching it. I'll just kind of show it to explain that it's a little bit of a different beast. So it's taking in like this DirectX 11 geometry and passing it out. It's the same kind of general idea again. You have some source nodes and you have some filter nodes. I think there's even a couple nodes that make geometry from like other things, like from formula or something like that. So in this one here, we've got as our kind of original geometry, just this icosphere. Obviously, we can actually use anything we want. A box might be boring, but just to sort of show it's whatever you feed into that. And it can be dynamic geometry also. We've got the kind of data type for these ones is this. You can see this like DirectX 11 geom. So I'm just to show, like, if you want to just kind of play with them, you can put in probably like 11 geometry or something like that, and there's quite a lot of stuff. Not all of these are. If you look kind of for the ones with the M there, that's probably the modules. I should kind of just mention I've been doing a big overhaul of all the compute stuff, and that's sort of finished now with the version that I've given you. I am gonna clean up the geometry stuff as well, but that's not done yet. In theory, it should all work the same way. Hopefully, it won't break anything, but no promises. Yeah, so we've got basically here we're doing. It's the same as the compute, where you kind of have the results of each pass always available. So you can see we're actually drawing two different things here. We've got this wireframe shader that's just basically drawing a wireframe of our mesh with the noise already applied. And then we've got this pipe frame one that's actually, it's kind of, you could say, somehow like data amplification for geometry, because it's actually taking the geometry and like making 3D pipes where the triangles were. Excuse me. So you can see here actually it's not doing all this instancing stuff. You don't have to do that. These modules will work with that as well though, and we'll have some examples with that too. I think in like the last version of DirectX 11 there was like a bug where any of the geometry modules, like they didn't, you had to kind of reload the patch or something for it to initialize. As I understand it, that's fixed now, but just to be aware if you're using an older version of DirectX 11, that might be an issue that you run into. I might just explain, quite a lot of the geometry nodes have like these indexing menus. And again, this is something that it's kind of just a convention that I used, but so if we look at the strength there, you know, you can see the strength default and the strength buffer. I think that makes sense for everyone. And then we've got this strength indexing. Now, if we change that, it doesn't actually appear to be changing anything. And the reason is at the moment we've got this switch here. So when that's turned off, we're actually using the default. So this strength value, it's just for how strong the noise is, right? So at the moment we're not actually using we're not using a buffer. Once I put it on, you can see now it kind of all looks the same, and actually that's because we're indexing it by instance. If we put it to primitive or to vertex, then we actually get kind of slightly different behavior. Now the reason for that is that since we're now using this buffer, basically what it's saying is, okay, you're giving me a buffer, but how should I distribute that? In this case, since we only have one instance, it doesn't really make sense to use one instance. But if we had like 2 spheres, then we could use that if we wanted to say that the noise should be this strong on this sphere and this strong on this sphere. When it's on like primitive or vertex, do you guys know what primitive means in this context? It's basically just if you have like on the graphics card the kind of fundamental geometry that it's drawing. So in this case, basically we're just talking about triangles. So if you're indexing by primitive, really what that means is we're indexing by triangle, and you can see kind of the triangles are sort of staying like as a form. If we're indexing by vertex, it means that each individual point will have a different. Yep.
Slightly off topic maybe. Could we sort the buffers?
Can we
resort?
Resort.
For instance, on a vertical level, to apply linear the vertices, could we sort them out in a way by
Doesn't that depend on the actual indexing of the geometry in the first place?
In general, you can do sorting on GPU. It's kind of I don't know, maybe maybe you know about it. Yeah, it's like quite a hard topic to do sorting. It is possible. You can look up things like bitonic sort or some other ones, but.
No, find another way to do it, bro. If
I
you apply it through a map or whatever, I don't know, but
I'm just thinking to maybe have a circular spread, maybe react centered to a point. But yeah, never mind.
You could probably do that without having to use like explicit sorts, but yeah, in terms of sort itself, I've kind of tried and failed a couple times already. Yeah.
Another thing that might be related, is it somehow possible to do depth sorting on the GPU? For instance, Noodles, for instance, if you wanted to have some proper alpha in your renderings.
Very much tutorial Saturday. Be there.
So like if you mean like if you have a bunch of instances and you just want to rearrange the order of them by depth, or
Right.
Yeah. No, it's definitely possible. It's not possible in instance Noodles. You don't have any sort nodes, basically. If you did, you could, but you don't, so you can't.
And so you have troubles with alpha when you have multiple instances that are not sorted?
Sorry?
If you have multiple instances that are not sorted in Z space, do you have troubles with alpha in instances?
No. That's what the
Should work.
that's what the graphics pipeline is actually taking care for. That's when it's rasterizing things. It's writing into the depth buffer. It's kind of like basically that problem is somehow solved. If you're doing something that's a little bit unconventional, like ray marching, then you need to take care for writing to the depth buffer yourself. But essentially here, all we're really working with is creating and manipulating geometry. At the end, we just have geometry, and it's not any different than if we were using the sphere at the top. I mean, obviously there's some effects being applied and stuff, but as far as what you're actually drawing or the shader that you're feeding that geometry to, it's just geometry, so it's not really changing the way the pipeline works.
But isn't that a common problem in normal pipeline as well? Like when you have transparent objects and they drawn in the wrong way, order them depth buffer actually doesn't work.
Yeah,
So that's the
absolutely.
same problem you have here, I guess.
I
mean,
Really? I don't think so.
don't think in this patch. I mean, this
that's
isn't
transparent.
actually using alpha.
That's the thing, that's transparent,
It is actually geometry. So.
it's only when you want to be an idiot and really don't have the alpha as it should be,
Like,
for whatever idiotic reason you may have, that then you will have to make your own use case. And it's not easy, but yeah. But what Kyle's trying to say is that in theory, this is taken care of.
By the
Alpha
GPU.
and sorry.
By the GPU itself.
Yeah, well, I'm not sure at which stage or where it's taken care of, but
Well, no, alpha and depth in general is a tricky topic. That's not necessarily always taken care of, but it's probably not the topic that we're doing now. Yeah.
Oh yeah.
just assume that they are making assumptions
Yeah.
which are generally correct in general common scenarios. If you want anything more fancy,
Like
maybe
in
we
the case
have.
of instances, of
Yeah.
course. Yeah, it's
Yes, if
Yeah.
you want to
specific.
use the noise with different spheres, lot of spheres, we will need to use the ID node.
We will, and I think that's probably the next patch we should look at. Yeah. Any other questions before we keep going? Yep. Also, look, I hope you're just like playing with these patches as we're going. Yeah, you can just muck around with it. I think it's kind of just always best if you tinker and see what does what. DMG instancing. Okay. Actually, probably yeah, it's okay. I'm gonna disconnect
Sorry,
that.
can I just ask you something?
Yeah.
I'm trying to help my man over here.
Mhm.
You've got 330M graphics card, compute shader, 10.1 DirectX. Somehow DirectX 11 stuff seems to work, but none of the instance noodle work. It crashes the computer.
Does it support shader model 5?
I couldn't find out exactly that. It just said compute shader 10.1, and I'm thinking that might be not enough for some of the instance noodle stuff, even though DirectX 11 mostly works.
Model 5 came with 11.
What's
Well,
that?
Model 5 came with 11.
You're right.
So
But
that's
what I'm surprised is that if it didn't have shader model 5, then the normal DirectX 11 stuff, like normal non-instance noodle.
Maybe
geometry-
because
I think
Stays in a way
there's
that
some
Cinema
DirectX
before, yeah.
10 stuff that is actually working with it, but when you're using like classes and interfaces and sort of thing,
There you go.
Yeah,
That's your
okay,
answer.
right,
right,
Yeah.
yeah, sorry. So I'm just going to turn the animation off in this one because it's distracting. I'd kind of like a simpler example actually. I don't want you to get distracted by sexy tessellation. Look at it, look at it! But yeah, so here we're actually working with instances. So we've got that same kind of sphere as a source geometry. So our normal geometry, yeah, and then here, like, it's not perfect, but the IID one is basically the go-to node for instancing in instance noodles. I should probably try to improve it at some point, but the way it's working at the moment is you just feed the geometry in and you give it an instance count. Those are the two most important ones. It used to have a nasty bug that it would crash if you connected it and it didn't have geometry on it already. So it kind of just has a fail-safe now where it'll default to a box. It was a bit hacky, but that was sort of just a way to avoid having a nasty crash. Yeah, it's kind of yeah. So.
Really fun.
What this guy's doing essentially is he's just taking that geometry and repeating it lots of times. It's a bit different under the hood, but you can essentially think you have however many lots of that geometry as you've given an instance count, but they're all then treated as one geometry. So like this instance geometry here, it's not like a spread of geometry anymore. It really is just one kind of big blob of geometry. And that's where this IID one is what we actually can then use to address that. So it's literally like if you've got, 16 points in each one, it'll say, okay, the first 16 are from instance 0, the second 16 are from instance 1, and so on and so forth. And that's what lets us then later do effects that are addressing those separately.
But sorry, it's important to note that the geometry instancing is problematic in the sense that it does kind of merge geometry together rather than cloning it. Therefore, you have to build some sort of IID, whatever you want to call it. That's what Kyle has decided to call it, but you need this sort of ID system if you want to specifically target.
I should also mention that instancing actually does entail a little bit of overhead too. Like just to know about, because often people sort of think of instancing as like some kind of silver bullet that will let you make millions of things and always be at 900 frames per second, and it's actually not. And in fact, in many cases, and this is probably a good example, I'm not using that many objects. In general, this would not even necessarily be like a case where you use instancing for getting better performance. It's more in this case about convenience. We're using the instancing because actually like a lot of these sort of buffered things and geometry ones, they don't take multiple geometry. So we somehow need to package it all into this single instance geometry. And then the point of it is that we can still address these separately. So that's kind of it as it is in this patch. The main advantage isn't about that it's going faster than if we'd just transformed those a few times. It's more that it's still then allowing us to use other buffered nodes that let us do things like tessellate them independently. Does that make sense? Yeah.
Regarding tessellation, is it possible to tessellate the mesh by texture, by control texture?
Yeah, actually, I think actually I've built it into this one even. It's actually done by texture array, which is kind of cool because you could use a separate texture for each instance if you want also. The nice thing about this texture array input is if you feed it a normal texture, it's smart enough to just take that one. It doesn't have to be converted into a proper texture array. But if you do have a texture array, you can use that also. So if you want like one texture that's defining exactly how this should be tessellated, and obviously you need kind of UVs on your model, otherwise it doesn't know where the texture should go. But quite a lot of the modules have textured inputs as well. Yeah.
But it is important to note that if you are going to be putting 3 quads on the bloody screen, don't fucking use geometry instancing. Like, you might actually end up with worse performance. I've tried it before. It's like, you know, you're cloning 100 models, stuff like that, then by all means. But I mean, if you're putting 3 quads, like, do us a favor.
Yeah. I've had people Skype me and be like, I used instance noodles and now the performance is worse. It's like, well, what are you doing? Okay, well, that's fair.
Don't be a prick about it, basically, guys, yeah?
So like it's probably not a super useful result, but again, just for getting this idea of the indexing, you know, if you put it to primitive, you'll kind of get this weird differing tessellation level on the same one. I mean, this patch is really built for it to be per instance, but just to know. So you know, you can think about if you just had a simple grid, you could really address how tessellated each part of the grid is, or things like that. You can make some nice effects actually with the texture and tessellation. You kind of end up just the more detail from the wireframe in some places is almost like a drawing or something. Gonna turn that amplitude down a little bit on that, and it's a bit more visible. So I'm just making this patch like a little bit more visible. So yeah, this is kind of actually an example of using textures. It's not a particularly beautiful patch looking at it now, but let's just concentrate on the technical side. So this Perlin node here is actually making some noise. I'll just show you what the output looks like from that. And it's a spreadable one. So you can see here we've actually got 6 textures. I can change the index on the preview and you can see that, oh, look at that. Nice. I wonder what that's about.
DirectX 11 bug looks like it.
Yeah. That's not my node, just to say.
Where's Vox when you need him, basically? His fault.
So that's why it's got the funny glitch from there as well. I was wondering about that.
Yeah, it's his fault, man.
Yeah.
That's why your graphics.
Anyway, a lot of people like this glitch aesthetic, so whatever. The point is we actually have a spread of textures, but it's a little bit confusing. In DirectX 11, you do have like an object called a texture array, but this is not a spread of textures. It is, but it's not. Like a texture array is a single object that has all the textures inside it, whereas a spread of textures in 4V is actually separate textures. They're spreads are kind of like an array, but it's a different thing.
We could just use one and transform it.
Yeah.
To go around this glitch.
Yeah. Or we could use like a completely. We could use anything actually. I don't want it to be distracting. The source. Like the source here is really actually not important.
Yeah.
So this is probably like looking a little bit weird because it's actually taking random images out of the Windows folder, but you can see it's still like just it's that you have the different images. I did supply one here called build texture array. That's just a converter. So if you have a spread of textures, that'll just kind of squish them into a texture array. So if you want to use like one of these geometry shaders. I should just mention again, it's very much the same kind of thing going on as like having this single item that's a geometry that's a collection of them all instead of a spread of geometry. Does that make sense? Basically, this like these geometry shader ones, they're not actually spreadable, but you can use these buffers, and that's how you're addressing it. So like it's actually the same thing. If we just tried to feed a spread of textures to this, it's only going to take the first one. But if we feed it a texture array, that's kind of texture array is almost like it's like the same as putting the spread of geometry into a single sort of instance geometry type.
One more question. For instance geometry, do you always need a why is there a second output for the geometry output? Do we need always a buffer?
No, you feed your geometry into IID, and it's IID that does the actual instancing and converts it to a bigger geometry.
Actually, do you mean this one?
Yeah.
Yeah. Okay, so that's a good question. So we've got like our geometry and IID up the top. That's just the initial copy of the torus. As we go down, the first thing we're doing here is the displacement mapping. So that's taking the textures and pushing them out. You can also control that by a buffer, by the way. Now here we're going to this tri-frame one, and the thing with that is that it's not like alpha or something. That's actually creating more geometry. So like if I take the width thing on this, I can adjust that. But it's actually like for every triangle, it's actually making a bunch more triangles. And because our actual geometry is different, we also need a new instance ID.
So there goes the
Does that make sense? Like what's that?
There goes the superphone for this one.
Triplanar is just a wireframe shader.
I understand, but
yep.
we can't use tri-frame with another shader like superphone.
No, you should be able to use it with anything.
I'm not sure it has the second input, because if I look at phone, I can't use phone.
There is a buffer you want, right?
Yeah.
But I think, sorry, don't correct me if I'm wrong, isn't tri-frame already just basically rendering the geometry
The only
as constant?
time you really need this IID is if you then want to be able to control things
Separate
sort of
color.
by instance. Does that make sense? Like I could just use I don't need to use this buffered one. That's only actually because I'm wanting to do some other controls on it that are also buffered.
Okay.
I could use this with like the normal Phong shader. I haven't tried it with Superfong, but unless it needs a special geometry type, actually it should be fine.
So I would have to translate it more up, put the translate more up, and then.
Yes, if you want to transform the single instances individually.
Because
You
right
know,
now,
you
if
have
I
buffer shader.
So that's right. Like at the moment, the actual translation for them is in this buffer here. I did actually make a node called transform buffered, which is also a geometry streaming node. So I'll actually just patch it now to show. So let's say actually that we I'm gonna make a normal constant. So take that there, and I imagine what this will do is it'll still draw everything, but it'll all be like in the middle. I'll make it black so we can see it again. So this is kind of the problem that you saw coming, that we don't have that transform anymore. But what we can do is, fortunately, we've already got that as a buffer. So we've got like this is a dynamic buffer transform. And if I now make a transform buffered, you can see this one. So it's again got this like geom effects type. Yep. Gonna grab that one. That will go on the transform buffer. You can see here it's asking actually again for the instance ID. That's just so it knows which one to apply it to. So we need to connect that. And it's got a geometry input, so I'll take that too. So that's basically, it's just taking all of the geometry that we have already and the indexing for it, and then it's applying that transformation on it in the geometry shader and then streaming it out again. So like the output you get from this is like pre-transformed. It's still just a single geometry, but then hopefully that will work when I connect it there.
right.
Yeah. How are we going for time?
It's just 12, 10 past 12.
What time do we get to?
20
I
minutes.
think we'll go until 1.
Do we?
Yeah.
No, I think it's 12:30.
Sorry?
No, maybe you're at 1.
No, it's
Then
1,
it's
bro.
already to-
Yeah, exactly. It's 3 hours. So
Yeah,
10
yeah.
till 1
Oh, that's all right.
and then 2:30 till 5:30.
Yeah.
Anyway, we might run over Pedro, and that's gonna be okay, bro. I'd love to see them trying to kick us out, bro. I'm gonna throw all my fucking nodes at them.
So actually there's like another kind of, this geom effects thing basically means, so like this one, it means it's a filter. So it's expecting geometry and it will give you back geometry again. You also have this one that just says DirectX 11 geometry. So like for example, kind of like the faithful quad or a grid or that sort of thing. And then there's some instance noodles nodes that have that same kind of tag for them, and that just means it's a source. So it's a node that you don't need to give it geometry. It's actually just creating geometry for you. And so like I guess probably splines is a really good example of that. We'll look at a more exotic one first. So this is actually like a surface formula, and it's
Paul Burke.
what's that?
It's the Paul Burke. Where's the formula from?
Oh, these are like you have many of them. So
It's from the Paul Burke website. Do you know? Because it seems like.
I think I actually basically copied the formulas from some of the older the older like
Does it look
surface shaders.
Oh, gotcha. Actually,
Yeah, like from the DirectX 9 ones.
This is the
Yeah.
Sanch stuff, by the way.
Yeah.
Yeah, bro. Sanch in the house, even though he's not. Big him up, bro.
He's very hated, man.
Nah.
He's too old for this, bro.
So
That's what he said, exactly.
I'm too old.
this one's kind of like a bit of an exotic one, but it was fun to make. Basically, the way surface formula works is you have like a 2D coordinate, and it's parametrically turning that into like 3D. So we've got here, if we look at the inputs for it, we've got like this resolution, and because basically what it's doing is it's making kind of strips out of the surface. So that's kind of like if I put the rasterizer onto a wireframe, you can see that like that's basically controlling the resolution of the grid, and you have these kind of like the P defaults and P buffer. That's a little bit of a vague name, just because what it actually means will really vary depending on which surface you're using. And there's kind of a lot of them. Like if I take this one and put it to list.
Well, I didn't know that list feature. Something I learned recently. I always change the number of rows.
So yeah, you can actually like use any of those, and the kind of the values that you'd use for those P is really depending on which one. So I mean, if you see with this one, it's kind of fairly intuitive. You can see what's going on. With some of them, they're maybe a little bit more weird to know what it's doing. It was kind of a fun exercise to implement them. Honestly, I've probably only ever used like 2 or 3, but you can look through them and find your favorites.
Look at the art from Sanch.
So 2006.
Yeah.
Super nice. Yeah.
The originators.
This is kind of one of my favorite nodes actually, and like full credits go to Unk. It basically was just taking some very nice shader work that he did and making like a kind of wrapper for the instance Noodles stuff. It's a little bit like the B-spline that we were looking at, insofar as you have a looped mode and a non-looped mode. So it's actually, I think, in looped mode at the moment. It's a kind of actually, in a lot of ways, it's working very similar to the B-spline modules in compute. It's just that what you're getting out of it here is actually geometry. And you've got like some different, you can have it as a tube, or you can have it as a ribbon or a square tube, depending what you're doing. Obviously the tube, if you have a lot of splines, it adds up to quite a lot of geometry pretty quickly. I'll mention like just one little issue with this one. Don't know of a good solution of it yet, but hopefully you have like this. If you look in the inputs, you have this one input called up vector, and basically what that's doing is, for the way it's building the geometry, you have the different points. And it's building a matrix for transforming it by taking one point and then another point and making a look-at vector in it. And a look-at vector is a way that you can just build up a matrix between 2 points, but it really depends on knowing which way is up. And so in this case, up is set to y, but if you have like a path that's going in particular ways, you may get like a kind of a twist artifact. I don't know like how I quickly can just try to make it do it.
Actually, if you do a spline on the y-axis and put the up vector on the y-axis or something like that, then you'll
I think even if I just change the up vector, we can probably...
Yeah, there you go. You got a twist on the left already.
Yeah, so you can see here, like that's actually not what we want, but Yeah, let me know if you find the solution.
Yeah, me too, bro. Me too.
Banking is an implementation.
It's called banking.
What's that?
Where you have
It's
to
an
flip it
implementation
every
for
time.
SVJS.
Oh, it's Houdini, it's called banking.
Yeah, but actually, I've seen implement. It's not that simple. I mean, yeah, to implement. I've tried, man. Bro, I converted this to Unity, and I tried to, as I was converting this, I tried to fix the flipping thing, and forget it, bro. You actually have to use a different lookup, because you can't, if you've got a node vector, you will get the twist. So you need to use a different method than a vector. Which, as you're right, if you have a second rail, like in Cinema 4D as well, you would have to use a second rail and stuff to do your proper spline wrap and stuff. Yeah.
It's not actually in Noodles yet, but like at some point was also.
Ooh. Work in progress version.
Oh, maybe it's not there. Somewhere I've got like a spline deformer as well that it's kind of built on the, kind of like after the Cinema 4D modifier. So yeah, like again with this one, it's just geometry that's going out. You can see here, actually, even though we're using instancing, we just have the completely normal shader there. That's just the stock 4V from directional. Yeah, I mean, we've got the IID there available if we want it. This is building it for us. But again, unless we're actually doing something here where we need to differentiate between them, then you don't need that. As soon as, for example, we want to color them differently or something like that, then you probably need a shader that has a buffered input.
Right.
Yeah.
And that's not something you could do upstream somewhere, like changing the color.
Well, yes and no, because all we're really taking out of this is geometry.
Do you have vertex color?
So you could add some vertex color, for example. But
you utilities for that?
actually, then your implementing shader also then needs to implement vertex color, and
Right.
really you're better off if you want like a custom shader to just use this IID. Because that's the information you need, and then you can make your own sort of buffers and inputs to your shader, and you have that to index it. What's that?
You need a buffer shader then, if you want to use the IID. To your point.
Yeah,
And there's only a few of those
Yeah,
buffer
I mean,
shaders you made.
generally,
Exactly.
if you're the thing with this is because it's instanced, even though we've got multiple ones, as far as the standard shader is concerned, it's one draw call. When you spread this, it will actually draw it multiple times,
Right,
but
but
we're drawing
everything,
everything,
yeah.
right? So I just want to show this because I think this can be a source of confusion. So I'm gonna take I've got my normal shader here, the Phong directional, and we're gonna put a transform on that, and that's cool, that works and everything. But as soon as we spread it, oh, sorry.
But the sub-mesh no longer a thing.
Then you can see we're actually we're spreading the whole thing, yeah.
Yeah.
With- Which sometimes that might be what you want, but in terms of like, shading them differently or coloring them differently, it's absolutely not. And then in general, what I would do is to just take that IID as an indexing buffer
No, of course.
for looking up into another buffer.
Yeah.
Yeah.
The subset you talk about.
Yeah, subset.
I don't think it's the same thing though. It's not a subset.
Can
When
you
you
have a subset of meshes?
Well, if you, yeah. I mean,
You're asking the wrong question.
Actually, like in terms of normally loading a mesh into 4V and having subsets, it's basically just a spread of meshes. So I do have a node that will take that and merge them into one mesh and also build an instance ID. But again, like at some point, you still, if you want to differentiate between that parts of that single geometry, you need a way to index
Maybe
it.
what he's asking is a node that does the opposite, from a buffer, from a one mesh, split it into subsets
No.
as a spread, so then you can use any shader and spread colors, and because otherwise you only have to use the buffer shaders that you made, which are only a few,
Yeah.
I think that's what it's trying to get.
Yes.
I suppose, yeah.
Yeah, I don't think there is a node to do that at the moment. I'm just trying to think if it would be practical to. I think you'd end up with quite a lot of overhead for like building the geometry.
Would you need a readback or not?
No, but I'd have to check. I'm not completely certain it's actually possible to do that in the pipeline. It may be.
Are you planning on making a few more shaders? Buffered ones, like phones and phones?
I
It's the
think
constant
I
improvement.
actually,
When it goes to that, it is.
I think I do have a phone somewhere.
There's a guru.
But sorry, you're slightly missing the point there. Is that a lot of the stuff in instance noodles is done with GSFX as opposed to GFX. Which what it means here is that it's both geometry shader, but one of them you have to do your lighting within the geometry shader. So you rewrite the phone essentially. So you do vertex shader, geometry shader, pixel shader. You rewrite the phone there. And you do your lighting there. Phone, torrents, whatever.
Very ergonomic for the user.
But the problem with that is that, for example, in V4, we already have a phone directional, phone point, whatever. Instead of every time you use an instance noodle geometry shader, you'd have to redo your lighting inside it.
Yeah, but to do lighting, you have to write the shader.
Yes.
What are you saying?
No, what I'm trying to say is that since instance noodle uses GSFX, the lighting is not included in the geometry shader.
Yeah.
And then
Makes
it's done after. Yeah, of
Yeah.
course, it makes
Yeah,
sense.
I mean, but this after one, if you want to have it buffered, you need to have a buffered version. That's what we're talking about.
Unless you make sub meshes.
Not for transforming it, but if
No,
you want
hang on.
to
For
if you want to
transforming
light
it,
things
yeah.
differently on a per instance basis, that absolutely has to be in your
Or even
shader.
just change the
Yes.
color.
Yeah.
Sorry,
yeah.
I thought you meant just.
No, I mean, we're
yeah.
talking about the.
Yeah.
And there's
Yeah.
just a guru and a constant and a sprite buffer.
Yeah,
But
yeah.
it could be cool to have more. I guess that's always saying. And maybe it's some other guys like the super phone guy could actually do a buffered version.
Yeah,
It'd be
yeah.
really cool, right?
Yeah, it's actually like not too hard to. It depends a little bit how the shader is structured. Like sometimes they have some bits that are in other files or something, but in terms of just adding the instancing part, it's quite straightforward.
We should try and push for that. Different shaders. Something special about this one.
Spongy though.
The colors.
Seafood?
So actually, this one doesn't kind of really have anything so new from what we've looked at already. It's just here we're again like using a kind of per instance spread.
The normals are pretty cool.
Oh, this is I think this is in Noodles. This one, this vertex attribute one is just like a debug view. So you have some different. You can go like through world position, world normals, UV, view position, view normals. It's quite useful for debugging some things, like if you're not sure what's going on with the UV map or something.
Yeah. Some people are building an aesthetic out of this look
Mm.
out there. You'd be surprised. Like
So-
normal map.
This one is just kind of like some of the really super classical deformers. You've got like this twist, bend, spherize, taper operations. I won't kind of go like through every single one, just encourage you to play with it. One thing I haven't actually mentioned at all, I kind of did say that it takes care of some of the stuff for you, like it's kind of formatting things. It also has this max elements pin, which actually in general you can just leave it. You don't need to do anything with it. But when it's on 0, internally actually what it's doing is kind of switching to like a automatic calculation. And basically this is just for the geometry shader. It needs to have an idea of how much geometry you're actually asking it to write. It's a little bit like a spread count for a geometry shader or something. So it can just do it automatically, and if you leave it on 0, that's the default behavior, and that's fine and it will just work. It does incur some performance overhead because internally it's kind of like doing a little read back. It's doing like a pipeline statistics query thing, and so basically it is just something that you can optimize also. Like if I take that max elements and I switch it to a number, I'll put it on something kind of high first. That wasn't high enough, obviously, but you can see that that's the maximum it's gonna do, right?
Where's this count?
I think so, yeah.
Elements though, it says elements.
Yeah, but I think
it is vertices though. Yeah. So now that I've set that, I've actually kind of gained a little bit of performance in my patch. In a lot of cases, it doesn't matter that much. But if you are using like really massive patches and you need to be optimizing, that's a really important one to know about because it does add up.
That's good to know.
But I'll add, because I played around with it a lot, this is what I do with this. If you have a fixed number of vertices and it's not changing, and you know you've got 7 elements, but as soon as you start spreading to 8, then the max element count changes. There's a few things you could do. You could try and guess the number by different calculations, like, okay, a box has 36 points, 36 multiplied by number of boxes equals pretty much that max number. It's not usually that simple, but you can find a calculation for it. However, if you put 0, it does it automatically, you lose a bit of performance. What I would personally do, and this is in a scenario where I know this isn't going to change, there's always going to be those 7 toruses, then literally you can just go down until you start seeing stuff that's missing, and until you reach the correct kind of number. So for example, you can see 300,000 is not good enough. And I'm just saying, if you know that it's not changing a bit more, then just find a number.
If you go inside in the sort of automatic computation one, does it say what number it finds? Maybe you can look it up.
Yeah, you can actually. But you can use you can use
Let's
pipeline
look it up.
statistics, which is actually what Kyle does in under the hood. So yeah, you
Read
could.
it in there.
Yeah, you could. Yeah, just
Maybe you
quite
should
right.
Maybe you could determine that when you say 0, just looks it up once and then stores it.
Yeah, but it's
And then it changes,
I mean, because like anything put in these modules, it's repeating every time. You need to be a little bit careful about like what kind of overhead it's incurring, because for every module you use, it's then appearing again then as a subpatch.
Or there could be a bank to recompute.
Yeah, a nice idea to just like take the last kind of valid value and
Hard copy this.
yeah.
Yeah, that's also. That's cool to know, because usually I just left it at 0.
So what else?
What's this? Geom deformer? Oh, did you just suffer? What's the max elements thing? Is this his view normal thing? Is it compiled? Something that says under the view normal? Some of the outputs of the yeah, vertex attribute, yeah. Compiled, yes. Just valid, yes. I don't know. Oh wait, layout valid 0.
So this patch is actually just demonstrating the merge node, and it's basically it's kind of just like a way to make this instance geometry, but actually when you have different geometrical sources for it. So like in this case, you know, we've got some boxes and some torus, but actually in the end, I'm wanting to draw them all with the same shader, or I'm also wanting to put some geometrical effects on all of them, even though they started off as separate source geometry. So like an example use case might be you have a 3D model and then also some procedural 3D elements, and then you want to put some kind of geometry effects actually on all of them together as one thing. So for that kind of thing, it's quite useful. Yeah, it's a little bit of spaghetti up the top here, but basically we're just using these cons nodes, so we're taking multiple geometries and multiple index buffers, and then the merge is just turning them all into one geometry and one index buffer. So it's again kind of like, you know, when I was saying just with the one geometry, it's saying the first 16 is from index 0, the second 16 is from index 1. It's doing the same thing, but it's just kind of adapting to the different geometries. So the first 16 is index 0, the second 16 is index 1, the next 8 is index 2, the next 8 is index 3. So you can still actually cleanly address them, even though there's different kind of vertex counts.
It's fine, it's fine.
Oh,
Yeah, resources. It's like
bloody hell, wasting my time.
Oh, sorry.
Is it part of like the geometry format you're passing along, or is it like just
You actually could build it into the geometry.
Up my stick by the
What's that?
USB is it?
Yeah. You're not,
What are you doing to it?
you're not gonna get back for wasting my time.
Working with like custom geometry types or something, and as soon as you have that as like a
Well, tell Sancho if you don't
component
nice,
for it,
He's your boss.
Yeah, you're gonna tell Sancho I'm gonna get my Q45 on my desk. You get fired.
Yeah,
Don't get me fired, please.
Sancho fire you, know.
It's just positioned in normal CD.
It's not good. I think if you behave.
Someone you can grab my spot there if you want.
Are we boring yet?
Yeah, what's wrong with you, Defecto, bro? we're just about to trash talk about you anyway, so you might as well leave.
That's why I'm leaving.
God, that guy Pedro, huh?
I only need the positiveness.
Which pen are you talking?
Yeah, which Pedro am I talking about? Good point.
Only positiveness. No, I'm just.
Thanks for being here, bro. We appreciate it.
You too, man. Thank you.
I won't kind of go too much more with these ones because I really want to be able to like have a look at what Mangosh has got going on here. Looks pretty crazy.
Yeah, Jesus. No, but we'll show the clean patch first so they don't think it's just some kind of fucking idiot.
So there's like a OBJ writer. It's okay. I kind of want to make a better one as a plugin sometime. But it has some features also. You can just kind of write geometry straight as is, or if you're actually using this IID, you can also basically write the geometry as subsets from your instance ID. So like the kind of difference being with that is that, you know, if I loaded these in Blender or Cinema 4D, if I was not using the subsets option, then it would load in your 3D program as an OBJ, just a single geometry for the whole thing. If we are using the subsets option, then assuming that your OBJ importer supports it, you should actually get like a single OBJ, but when you open it, you'll be able to kind of access each individual instance separately.
Which is a dope feature, we all agree, if we are writing the models. You know?
That's the only format.
Sorry?
There's a writer only for OBJ, not for any other.
Just OBJ. Yeah.
Which is fine.
Yeah. Yeah. I mean,
Which is
it's
fine, Simon,
it's
thank you.
just geometry feeding in. So like if there's other writers people have made, you should be able to use it with it actually. But that was kind of the only easy one I could find to make.
Anything else pretty fucking hard, to be fair.
Yeah, like
we are
this,
not
this,
that good.
this FBX stuff that's is crazy. Yeah, yeah.
This Pixar format seems to be really good. This what do they call it? You know, the unified.
Oh yeah, what is it again? Yeah, that's quite new as well, this thing,
It's
isn't it?
actually pretty powerful.
So you think it's gonna replace APX?
Just quickly before we switch to Mangosh's demo, I just want to mention, like on the side, there's some of these volume nodes. They're mostly working with like sign distance functions, and It's kind of a whole topic in itself. Basically, the idea with signed distance functions is you have like a mathematical function that's kind of describing a surface. In instance noodles, you have a few kind of in this DirectX 11 volume category. They're almost all actually somehow to do with distance fields, and what they're doing is basically it's writing a 3D texture with it. So it's quite flexible, but the resolution is quite limited. For much cooler kind of stuff along those lines, I highly recommend Field Trip. It's this.
Oh, I thought you were going to mention my workshop. We didn't rehearse this enough, obviously.
You're doing a workshop.
Never heard of it.
When is that?
Saturday, last workshop in the afternoon.
It's going to be
If you
pretty
are not
trashy.
there, if you're not there, my friend Pedro, and I don't mean this friend Pedro, my other friend Pedro, much scarier, will find your hamster and beat it up to death. So come on Saturday if you don't want to get in trouble, yeah? They don't look at me like I don't give a shit, I ain't got a hamster. I will find a hamster for you and we will beat it. And you'll be responsible for this. What's that? Sorry? What, beating up the hamster? For sure, bro. No, it's a tutorial. The workshop will be recorded.
Yeah, there we go.
Then I'll find your bloody hamster.
Okay, so lastly, and then we'll go back to Mangosh. This is like a marching cubes implementation basically, but I think it's named just SDF to mesh.
Super useful this. I will mention this in the remarching tutorial actually. This is essentially taking SDF, which is making shapes with math rather than polygons, and turning it into polygons. Math? Yeah, but not just now, man. Wait for lunchtime, bro.
That's our slogan. Math to polygons.
What is in Germany? Kein Bier before fear. It's like kein Mess before lunch, you know.
So do you wanna switch over?
Yeah, I'll show this wandering spline thing, I guess.
Did you on this one? Oh no, that's all good. I thought you wanted.
Yeah, I'll just show this thing first, I guess, and then maybe show this. But it's pretty scary stuff.
Don't keep us waiting.
It's gonna be sexy shit, bro. Did you try this? Is it working?
It's all broken. Everything was red, dude.
Wait, it's your fucking library, bro. Oh, it is working, bro. And I cleaned this up, and the wireframe shader's not working.
Yeah, it's just that.
Oh, it's working now.
No, diagonal never actually did anything, so I took it out in the new one.
Full screen.
Full screen.
Second meth.
This is what happens when I smoke too much crystal meth on a Saturday, bro, in my brain. No, but this is all instance noodle shit, and I think it's quite a good example because it really makes most of instance noodles modularity and general ability to take a little something and just keep on building onto it and building onto it and building onto it. So I'll kind of go through first by just looking at it rather than looking at the crazy patch, kind of what we got. What we got is spline buffered, the spline stuff, and then some of you guys were in the DirectX 11 advanced shader shit and whatever, so don't mean to sound like Vox because I'm not that clever, but this is using stream out rebind, so spline buffer, stream out, and then rebuild some geometry shader shit, repass it. Those cubes as well that you see, this is geometry instancing, transform buffered. Then we use stream out rebind. So what happens is those cubes are instanced, and then I stream out the position of the vertices, and then I instantiate particles from it. So basically you take a cube, clone this cube along the spline,
then take these cloned cubes along the spline's vertices position and use that as the position of more instancing. So it's almost kind of like recursive, instance noodle shit.
But you could have built everything from the path already.
Sorry?
You could have built everything from just the path.
Yeah, that's kind of what I'm about to show, that it's all built from, I believe, the control point. What I'm trying to do is that it's a bit like me, it's a bit hectic at the moment and it's going too fast. How can I slow this fucking thing down? I think integrate, isn't it?
Speed.
Yeah, where is it? I thought I'd put it, yeah. Oh. No, actually that's the speed of, I know, yeah.
You can set the main loop if you want.
Yeah, no, that's cool. I just do.
That's the camera.
Yeah, I guess it's a bit slower now. Yeah, okay, cool. Oh, and we've also got some look at stuff. So I'll kind of go through this quickly and try and explain kind of how it's done. A bit of a big patch, but it's mostly because I wanted to show how things are being chained rather than, putting everything in sub patches and then you don't know what's what. But what happens is I'm using the new really cool, actually this has got some VL in it, bro. I'm not gonna pretend that I actually developed in VL, but this is a new VL node called Wanderer, which essentially does, how do you close VL? What?
W.
Yeah, still?
Yeah.
Alright, bro. And in fact, if you look at the F1 patch of the Wanderer, there you go. So the Wanderer gives you this kind of wandering position, and everything is built from this essentially. So you have the Wanderer gives you 60 positions. 20, just obviously X, Y, Z. So you've got 20 splines. It might not look like it, but there's 20 splines. So you have therefore 20 positions. If I remove this apply transform and go straight to it, then it looks a lot less cool because they are not spinning anymore. So they are just, are they? They are spinning. Okay, so I'm obviously talking shit. Never mind that. Essentially, apply transform is making the twist bit, so you'll see they're like, generally they'll go like that, and then I use apply transform to make it twisty with some wave shape or bullshit thing going on. Oh, let me see. Yeah, direction switch, let's just ignore that. What happened then is we take these positions that are twisted, so where here you go apply transform, here it twists the position. So the position are only the end position. So when I say 20 lines, it's the 20 end points of the line, and that goes in a queue. So that's how I build a spline. So essentially the Wanderer, all it does, it gives you a position that goes like this. And then if you put it in a queue, well, obviously you're gonna have, the queue like a, and that's how I build the control points for some resampling bullshit going on. But essentially in the end, it goes in spline buffered through a dynamic buffer, so that's your control 3D buffer. So these are your control points, and from those control points I then reuse them to instantiate for it. This is where the boxes are being instantiated. So we have a box, IID, transform buffered as you know it. The input is, we got look at, bloody hell, obviously. So instead of just putting the boxes instanced directly on the position, I also use look at, which is another module for instance noodle module, which allows you to basically align things along the spline. So whenever you want to do align to spline, anything like that, use look at, and it will.
You can use it in other contexts as well,
Yeah.
but that's like a good use case.
Yeah, that's right. Yeah. And so in this case, what look at does, if I didn't use look at, then all the cubes would just go like that. I mean, they would move up and down, but they wouldn't follow the direction. And what look at does, as you see, is that the cubes are rotated according to their current direction.
Can we remove it then? Can we not
Sorry?
just connect the dynamic buff directly to the...
Yeah, bro, I can probably bypass that shit like this.
There's actually a module that wraps pretty much what
Yeah,
you've
you
done
go.
there called heading also.
Sorry?
Like if you make a heading module, just to show, because it's basically just a wrapper for what you've got there already.
Heading.
Except it has to move.
Heading transform buffer.
Yeah, the heading transform buffer, you.
Yeah, but look inside it,
Yeah.
Used to look at it.
just to show.
Ah.
Yeah, but it has to move in order to work. If you stop it,
Yeah, because it's frame.
Yeah, if you stop it, it
Yeah.
detects that it hasn't changed and doesn't
Because
change it.
yeah, it uses the direction, so if you don't move it. But as you can see, without it, obviously all the cubes are just going
because
straight and not
the
being
spline
rotated.
doesn't give you a tangent or something, right?
That's right.
Yeah.
It works with direction look at, so it's looking at where you're moving. If you're not moving anywhere, it just goes 0, 0, 0, therefore.
But you do have a spline, so you could use the spline derivative or.
Yeah, but
if there was such a thing.
arguably the spline derivative would be equal
It's,
to the direction because
There is a function in that fxh file called spline that has like a version with the derivatives also. The problem with kind of these ones that have like extra outputs and things is it's just at some point hard to fit into these kind of like standard module types that using in this pack. Yeah.
Yeah, it's the idea is to keep it simple as well, right?
Yeah. Actually, like I don't know. It was kind of like the sort of design idea around it was to make it simple where possible. So that was always coming somehow before like flexibility or performance. But I think it's somehow an okay balance.
yeah, so just trying to go through this to show you all the tricks. I thought you replaced that actually. That compute. What was that replaced by?
You've got that position from matrix or matrix.
Hang on, let me just put back the lookup. I'm just going to put back the lookup here. And you can see as soon as I put back the lookup, the cubes are obviously moving correctly. The orientation's changing according to the movement. And this is where I create hang on, let me just stop it from fucking running, actually. Sorry, I'm just running it a little bit so that it actually runs, and then...
It's a camera somewhere, no?
The fuck, man, shouldn't you just actually stop it from running?
You would have to freeze everything, including the queue, because you're queuing the code.
Alright, I just forget it, bro. Sorry, man. I'm just gonna have to run it. But yeah, essentially, there's white lines, you know what I'm saying? The white lines here, they are, as I said, created from a stream out. So what we do is we instantiate the cubes all around the spline, and then we take the position of all their vertex, and we use that as well, fuck knows, I can't remember. Hang on. Stream out, streams it out. This is where it streams out. So I made a compute, but actually I didn't know there was a module for that in Einstein's Noodle. Essentially all this does is... Oh, you've just changed it, have I? Oh, fuck knows.
No, I didn't.
It just extracts the XYZ.
You're just wanting the position from a
That's
matrix buffer.
So it's like
Actually,
using...
there is a node to do that.
Yeah, it's
as a buffer.
But it's
translation
kind
to
of a
matrix.
good illustration though of like when you're not using the modules, if you're just setting it up, like literally, actually all of this is replaced by just one node.
Yeah.
So it's kind of nice that you don't have to do all the dispatch and data wrangling.
And then this is where we start bringing compute shit from instance Noodle, like oscillator. So I've got my cubes moving like that. As I explained, I take the cube, I get the vertex positions, and then I put this position is a 3D buffer. So what I'm saying is you realize I've got my cube transform, all my cubes transform. I happen to use my own compute shader to convert. Essentially all it does is convert a transform to 3D buffer. As Kyle said, he did have a node for it. I was just too stupid to see it. But essentially what this does is take a transform, make it into a 3D buffer. Once it's a 3D buffer, it's party time, bro. Oscillator, anything you want in Instance Noodle from the node list here, 3D buffer, it's on. We can just use any of those things. I just happen to have chosen oscillator and 3D noise. So you have your cube like that, we get the, let's say the vertices like that, then oscillator, what happens is oscillator takes those 4 values and oscillates them, so each value is kind of going a little bit like that. And then we have also some 3D noise with a simple operation. So what we see here is again chaining shit even together, adding it. So it's not just, this is a good point actually, you could run an oscillator 3D buffer into 3D noise. Can you actually, that might be a bad example. It doesn't matter. You could run an oscillator 3D buffer into another node that does another thing to it, like curl or whatever. Or you could add them together. So what happens here is that we've got my cube, vertices oscillate, and at the same time as oscillating, I'm adding 3D noise like that. So it's like oscillating plus 3D noise like that, whatever, it gives it a more natural effect, I guess. And that goes in sprite buffered. Sprite buffered, that's your basic particle system instancing shit where you just put in transform, or is it XYZ? No, 3D buffer, you put a 3D buffer and then it makes a particle system from
No,
it.
you shouldn't.
So
Yeah, I think
this is the white things that are behind it. These white lines that you see around the cubes, right? That's what creates those. For the actual particle system, and I think that's a good point because they use both sprite buffered, as you'll see, there's also a particle system in here, which is all the particles here around it, which you can see better when the camera gets closer to it. All these particles, that's also entirely done in Instance Noodles. And that's like, looks kinda like something like this. And essentially we change shit this time. So we go Brownian. So just Brownian is just something that makes the 3D position kind of shape.
It's a little bit like that Wanderer node somehow.
It is actually.
Yeah.
It actually is.
Probably
It's
just less controls on it. It's
bit
just
more
a bit of randomness.
random, but essentially we're chaining shit here. Brownian. So Brownian takes maybe 50,000 initial positions, reset position inside it, but depending on your spread count, which is 100,000, not too bad, pretty fucking decent, bro. And so they initialize the particles around certain random position and then kind of shakes them. Then do we go? This is fucking awful patching style. I do apologize for it, but anyway, so it goes from Brownian to oscillator. So as I explained first, Brownian makes a cube of particles in 3D space that are shaking. Oscillator makes them kind of come and go, a bit like wind oscillating, really. Then we use map, because what map does is it just scales the whole thing up and down, essentially.
Yeah,
right?
you can also use the modes on it a bit. Like if you want some just random items moving about, but actually you want them to be constrained within an area, you can use like the I think the mirror mode or something like that. So you've got like these mappings like map and clamp.
In fact,
and mirror.
what's the mode on this map? Mirror.
Yeah. So it's just preventing.
So if a particle comes out, it comes back on the other side or comes back like that?
Yeah, it'll kind of ping pong. So
Yeah. So and you know what? In this example, map could have been ignored if I was more careful as to where my original Brownian position were, and that's more of a hack. I just think map is basically you do your particle system and then maybe later you drop in a scene and you're like, fuck, the particle system like this big and the 3D model is like this big. With map node you just go and then scale it up, so it's super handy to have it. Then we have shit, 16 or 20 attractors. Actually, I was surprised how fast this runs, even with the serious number of, well, serious.
Can you bring
decent-
an inspector up on it, on the attractor node?
Yeah.
Yeah, so like, I just want to point something out on this one because it's sort of defying the convention a little bit. Normally with instance noodles, you don't usually have spreadable inputs in the conventional 4V sense. You have like these kind of single value ones, or you have the buffered ones, which you can then feed a spread to if you want, but that's a different thing. I've tried occasionally when I skip that to just make it clear in the name. Like you can see how it has a plural there. It says attractors instead of attractor. And so that's just like a hint that you can spread it. And the reason for that is if you look inside, all it's really doing is it's already got like the dynamic buffers set up. And the reason for that is because like with the attractors, for example, you might have a very, very large amount of items that they should operate on. But you're not really gonna have more than a dozen or a couple dozen attractors typically. After that, it will start to
20,
get
bro.
very expensive. I mean, you've got 20 now, but you know what I mean. Like,
Yeah,
like
totally.
basically, otherwise, every time you use it, you would kind of always be needing to attach these buffers, and so it's basically just taken care for in the patch. And so as far as you're concerned, like in the but yeah, you can. As far as you're concerned, you can just treat it like a normal spreadable input. It probably won't like it if you try to use 1,000 attractors or something, I guess.
Yeah, I don't think it would. But so for us, in that example, the attractor's position is the first box. So like first box, that's your attractor position, and there's one per spline. What it does is because he's got a minus attraction, therefore that's why when the splines go through the particle, they are pushing them out a bit, which creates those like quite nice looking circly areas around the actual fucking thing. But after that, that's kind of it. Like then we go in a sprite buffered again. This is kind of showing off how, there you go, you put like 4 or 5 instance noodle modules and you've already got a decent particle system running and all this stuff. So
Can you quickly trigger with that? to
Sorry?
see- Can you quickly trigger with that to see how it's running?
So the particle, it's all these particles, I would say.
I mean, there's this reset switch. So actually, if you triggered it, wouldn't we see like the original volume position?
Yeah, I think I just need to reset here. Hang on.
There's a send reset on keyboard.
Hang on.
You have a keyboard thing.
Oh yeah, there was a keyboard key, sorry bro. Yeah, I think as you see when I press reset, I think the, am I right to think the Brownian has like a reset position, isn't it?
I think it should do, yeah.
Yeah, so it has a kind of default position, and then map is also kind of sticking the particles where they are, but then the particles themselves are being moved. Are they being moved or? I'm sorry. Yes. So it's a bit. There's a little bit something else going on actually. I've just realized is that the map node, the bounds of the map depends on the mean position of all the cubes. So what I do is I take all the cubes, I do a mean position, so I get basically the middle position, right? And that you add 2 to it and remove 2 to it, and that's your bounds for your particle system. What it does is that when the splines are moving, the particle system is generally moving.
And you're not doing that in compute, that's just working the bounds out on the CPU,
That's
because it's
right.
not that many items, and using the kind of normal inputs. So it's kind of a good example. You don't have to think about, oh, I'm just doing it on CPU or just doing it on GPU. Actually, generally the best is to kind of integrate it where you can.
Yeah, and I'd say because in this sense, I'm only just playing with 3 values, 4 values here and there, it totally makes sense to do it on the CPU like this.
Did you want to show something more? before
No,
we wrap
I
up,
think,
or-
to be honest, I think, because if I start showing something else, then I'm going to talk for the next fucking hour and no one's going to get lunch. That's it, bros.
Thanks very much for coming. I'm sorry we kind of ran out of time. I did say we'd talk about like some of the shader side of it as well. If anyone's interested in that, just come like hit us up during the week. Very welcome to. If you want to like know more about the kind of shader side of it, or how to like adapt a shader so that it's buffered inputs or this kind of thing, just let me know.
And yeah, just obviously you haven't heard of this, but there's a really cool ray marching workshop going on this fucking guy. See you on Saturday, bros. Any of you not coming, I will find you and drag you by the underwear.